Okay, 7th grade, you should be doing lesson 5.5 warm-ups.
Yes.
Go. This lesson is, we're going to graph proportional relationships. Okay? Find the quotient. Okay, what does quotient mean?
Answer of a division problem.
Thank you, answer of the division problem. So you're dividing these. Negative 3.3 divided by 2.2. And you're writing it as a decimal. Okay? Okay, a constant of proportionality. Somebody tell me what is the definition of a constant of proportionality, Joaquin?
The number k. Wait. It's like 5 seconds. Two quantities x and y are proportional when y equals kx, where k is a number and k equals or equal cross whatever.
Does not equal. That's what that means.
0. The number k represents a multiplicative relationship between the quantities and is called the constant of proportionality.
All right. Now tell me in your own words what that means.
Well, I don't understand it well.
That's right. Do you know what it means?
Like two problems are equal, like the same, or
So the constant of proportionality is telling you at the change, the rate of change that's the same the whole time. So when you draw a line, it's got a specific slope, right?
Yeah.
Okay, it's got a slope that's at an angle. It's always the same slope. It's going to go up 1 over 1, up 1 over 1. That's a constant. The slope never changes. So the constant of proportionality is just telling you that. See how k is right here?
yeah.
It's telling you that this will always change by 2. Okay? 8th grade should recognize this. This is the beginning of how to learn about how to find the slope.
Yeah,
I remember that.
Okay?
I should remember it.
All right. Let's go do the example. Put this in your journals.
Okay.
So we're going to tell whether x and y are proportional and explain our reasoning. So they've given you a table.
Yeah.
So we need to look at this table and find the constant of proportionality to determine whether this is proportional. So the first thing you're going to do is plot the 4 points. Okay, so how would I plot my first point? The first point right here is 1 comma negative 2. So start at the origin. Which way do I go?
Down.
Nope. Start with x.
The side,
X is left to right, and it's a 1, so I'm going to go over 1. Then I go which way?
negative 2.
So up or down?
Up.
Down.
It's a negative 2.
You can't go down. You go down.
The graph says negative 2 on
Right here.
Yeah, but on the graph.
That's not a negative. That's the blue line behind the chart.
Huh?
Negative 2 is right here. Okay, so there's your first dot. Okay? Negative 2, right here. 1 comma negative 2. Okay, my next point is right here, 2, 0. So again, start at the origin. Which way do I go?
Right.
To the right 2, then up or down?
No, you just stay there.
Just stay right there. It's a 0. There's my next dot. You should be sketching this.
Oh shoot.
Okay, my next point is 3, 2. So starting at the origin, go to the right how many?
3.
3.
And then which way?
Move up 2. Toothpick.
Up 2. So right here.
Yes.
Very good. Okay, and then the last one, 4, 4, I start at 0 and I go which way?
Right.
Oh,
4.
up.
To the right 4 and then what?
Up 4.
Up.
And then up 4, put another dot. Okay, if I were to connect these, is that a straight line?
Yes. Yeah.
Yes.
No,
But
not
we
yet.
just draw a straight line.
That's a straight line.
Yes, it is, teacher.
From each dot, I went up 2 over 1, up 2 over 1, up 2 over 1.
Thank you, teacher.
So that's a constant. It doesn't change.
Yes.
However, does the line pass through the origin?
Yes. No.
Where's the origin?
0. Right.
0, 0. The line does not pass through the origin. In order for this to be a constant, proportional constant, it has to go through the origin. So the x and y are not proportional. So those are the 2 ways you check. Make sure the change is the same the whole time, and does it go through the origin? Okay?
Yes.
All right, let's do the second one. B. The first point, 0, 0. Where do I put that?
Right in the middle.
At the origin.
At the origin, 0, 0, right there. Okay, the next one is where?
Move 2, go go up to?
Move to which way?
Right.
Right.
To the right, to,
Then go up to.
up to. Very good. What's the next one?
You go
Right.
four right.
times. Then
And then go up 4 times.
Very good. And the last one?
Go right 6 times and
Then
go up 6 times.
Very good.
This seems very hard. No, I'm just kidding.
You're just graphing.
Come on.
Okay, and now draw a line connecting those. Does it look like a straight line? Yes, from each point I went up 2, over 2. Up 2, over 2, up 2, over 2.
That's pretty easy.
You could even simplify it and say I went up 1 over 1. See? 1, 1, 1, 1. So that's definitely proportional. Now, does it go through the origin?
Yes.
So this x and y are considered proportional. So you would say yes. Okay? Go do your try-its.
Start. No.
All right, example 2. Write this in your journal. The graph shows the speed of a subway car. Find the speed in miles per minute. So we have the distance in miles and the time in minutes. So we're trying to find miles per how many minutes?
Half.
Per minute.
Minute.
Which is how many minutes?
What?
1.
No, me. Yeah, 1.
Minute means 1. So we want to find how fast the car is going per minute.
Yeah, Joe.
So if I go to the number 1, that would be 1 minute, yes?
Yeah.
How fast is it going?
Half a mile. Oh, no.
One minute.
One
One.
and one and one. Oh, half a mile.
Half a mile per
Minute.
minute.
I did it.
Okay, so you figured out how to read a chart. Excellent. Half a mile per minute. But let's look at the proportion. Okay, so we're going to use 2, 1 up here
Yes.
to find how fast we're going.
Yeah. Yes.
There's 2 different ways you can do this, by the way. The point 2, 1 indicates that the subway car travels 1 mile. See up here, 1 mile every 2 minutes.
Pretty slow.
Whoa. It's a train.
1 mile
Oh, never mind.
every 2 minutes. This is pretty quick.
Never mind.
That's like.
Instead, I was thinking of an airplane.
Yeah, okay, that would be slow. Okay, 1 mile every 2 minutes. So if we reduce that to over 1 minute, you can see that we discovered it's half a mile per minute.
Wow.
We figured that out by looking at the chart, right?
Yeah.
Okay,
Yeah.
so the second way is to use the point 1, 1/2 right here,
Okay.
which is what we did when we looked at it. Okay, we said, okay, it goes half a mile every 1 minute.
Wow.
Yeah, I don't know why they took forever to explain all that.
That's
Okay.
nice.
Excellent reading the chart skills.
So 1/2 of a mile in one. That's pretty easy. I could do that in my mind.
Yep. Okay, so the constant is x here. It's that half a mile. All right, go do your next set of try it. Next try it number 4. And then self-assess 5 and 6, okay?
Yes.
This is missing.
Okay, example 3.
Teacher's math.
The graph shows the area, represented by y, in square feet that a robotic vacuum cleans in X number of minutes. Find the area cleaned in 10 minutes. So if you look at this chart,
Yes.
as we go up the y-axis, this is how many feet it's cleaning. Square feet.
That's a lot of feet.
It is. If we go along the x-axis, this is how long it takes them. Okay, now it only goes up to what, 4 minutes?
Yeah.
How long are we wanting to find it for? So if we find it per 1 minute, could we solve? Yes, we could solve for the 10 minutes.
Wow, that's
So let's figure out how long it takes to clean an area for 1 minute. Go on the chart to 1 minute. And go up, and it tells you how many square feet does it clean. 16 square feet per minute. Okay? So the constant, or k, is 16. So you're going to plug that into our equation. Y equals 16 times x. Okay, because our constant is 16. Now, now they want to know in 10 minutes how much does it clean. So where am I going to plug in the 10?
X.
Why the x?
Because it's multiplied.
No.
Oh.
Why the x? Why where the x is?
Um.
Because the time is on the x line.
Oh, that's nice.
So we plug 10 minutes, that's time, where the x is. So you're going to do 16 times 10.
160.
160 square feet.
It's 116. I'm just kidding.
It is 160. Now this is a word problem. 160 what?
Minute. Square feet.
Square feet. Excellent.
Aww.
We did it in 10 minutes. The robot cleaned 160 square feet.
You did 160 minutes.
Talking about our negative.
No.
Not really good.
Okay? Any questions on how we did this?
Science kid.
How does that not make sense?
It doesn't. You can't clean 160 minutes in 10 minutes.
It makes sense.
No, it doesn't.
Does it?
Okay?
And put SQ.
Yes, you may put SQFT. Square feet.
Minute.
All right. That's your assignment, guys. Finish all the way through self-assessed number 8. It is due tomorrow.